Chapter 10.6 Pulleys. In this chapter, nothing much to learn, just one small thing. When we work with the sums, sometimes they will tell that it is a smooth pulley. If it is a smooth pulley, then the data we have to absorb from there is the tension in both sides is same. If it's not, so the data we have to absorb that the left side is, let's say, T1, the right side, the other side tension is T2. If it is this kind of place, if we place the pulley, so from here, if this is a smooth pulley, so this is also T, this is also T. If it is a rough pulley, then from this point onward, this is T1 and this is T2. So that is the only thing. So if it is smooth, this is T and this is T. So basically, this is T. The word smooth is usually when we apply, so the tension is same in the string in everywhere. All you need to know, and we'll discuss the example 13, and then we have to use usually the sense. For example, if there is a pulley and if we hang two particles, let's say this is 2 kg and this is 10 kg, then it is obvious that this is moving to this direction. That's all the sense required, and then apart from that, everything is as usual. In example 30, we can see that this is a pulley. So this is a smooth pulley, as a smooth pulley, and two particles, 2m weight and 3m weight, hang on this one. So this is going to be, the weight is 2mg and this is 3mg. Mass is 3m and 2m. And the tension is same. So because of these weights, there's a tension created, that is T. So this tension is everywhere it is same as this is a smooth pulley. Um, Now this system will release from the rest. Then what will happen? This side has a high weight. Because of that, it will uh, accelerate towards this direction. So let's say this is A, and when it is going towards this direction, this will go up with this direction. And in here we can't consider whole system. There is no such thing exist, because the acceleration in two directions. So because of that, we have to consider system separate. Now there are three systems here: this one, and this one. So I will write this is as F in the example. So we have to consider, if we need to find F, we have to consider this one. And the question A, write down an equation for motion of P. So this is P and this is Q. So F equal MA to P for this direction. When you apply, there are two forces on this particle. One is T, another one is weight. For this direction, up direction, T is positive, and this is opposite direction. Because of that, that is negative. So T minus 2 mg equal m2m. So weight is 2m times a. And for particle q, F equal ma to q. So it is going downward, so I put downward direction. So 3 mg is positive, 3 mg, t is the other way around, so it is negative. The weight is 3m times acceleration is a to this direction. So this is 1 and this is 2. Now find the acceleration now. We can see that when we add 1 plus 2, this t to t cancel out and we only remain in 1. In other way, two equations and two unknowns a and t. So we can find. So 1 plus 2 t minus 2 mg plus 3 mg minus t equal 2 ma plus 3 ma. So this is cancel out. So this is going to be mg equal 5 ma. So m to m cancel out. A equal g divided by 5. So g is 9.8 divided by ms minus 2 approximately. This value is going to be 1.96 ms minus 2. Part C, we need to find the tension. So tension we can, in this one and this one, tension there. So we'll use this one. T equal 2 mg plus 2 ma. So 2 m times 9.8 plus 2 m times g is acceleration is g divided by 5. 9.8 divided by 5. 2m I'll factorize. 9.8 also I can take it out. 2 times 9.8 m. So this is going to be 1 and this is going to be 1 over 5. So this is going to be 6 over 5 times 2 times 9.8 times m. This is going to be 23.52 m. Part D is find the force exerted on the pulley by the string. So basically we need to find the F. So for pulley, we put F equal ma to any direction. So the forces, there are three forces. F minus T equal. So in the sum they will tell that small. That means the mass is 0. So this is 0 and it's not moving as well. So acceleration also 0. So F minus 2t equals 0. F equal 2t. So F equal 2 times 23.52 m. So this is going to be 47.04 m. Next question is find the distance moved by Q in the first 4 seconds, assuming P does not reach the pulley. For example, now this is starting to coming down, and do you feel that this will go and stuck on the pulley? To avoid that thinking, they have given that assume that P does not reach the pulley. So it means this string is lengthy enough, long enough, and this is now we have to start in from rest. So u equals 0. Acceleration we know that g over 5, and we time taken t equal 4 seconds to touch this floor. Actually, it doesn't touch the floor. So first 4 seconds. So flow is still here. Assume that the first 4 seconds. So S equal ut plus half a at square to this direction. S is u0 times t is given 4 and half a value is g divided 5 by or 9.8 divided by 5 times t square 4 square. So this is going to be, this is 0, 9.8 divided by 10 times 16. So answer is 15.68 meters. Next question is, state how you use the fact that the pulley is smooth in your calculation. So from here it will make T tension, and this is so in this side it make T tension, and since this is a smooth pulley, this T bring to here, it is going to be same. As a result, this pulley, oh sorry, this particle also get the same T. So the tension in the string in the same at P as at Q. Example 14, A and B two masses in a horizontal table. We'll draw this one. So this is the weight is given on particle A, that is 0.4 g, and this is 0.8 g, and the normal force is R, and there is a tension T, and the tension, this is a smooth pulley, so tension is everywhere same, and there is a restriction for, so this is moving to this direction, and as a result there is a restriction on this one. Sorry, it's resistance, which we call friction, 0.08 g. Now they will tell this point is 4.9 meters, and this is B particle. The first question is the acceleration of the system. Then there are three setups here, this one, and this one pulley. So we'll consider both particles separately because we can't take whole. This is in this direction and this acceleration is this direction. So but they have the same acceleration. If this is A, this is also A. So we'll consider particle A. If we equal ma to this direction, we can see that only the T is there. T equal weight is 0.4 times A. Actually, T is here. T minus friction force 0.8 g, and this is 1. So particle B, F equal ma downward. This is how we have to always do. 0.8 g is positive and minus T equal 0.8 times A, that is 2. Now we need to find the acceleration. So we know that when we add those two together, T to 2 cancel out. So 1 plus 2. This is going to be cancel out, and 0.8 G minus 0.08 G equal 0.A plus 0.8A. So 1.2 A. This is going to be 0.72 G. So A equals 0.72 divided by 1.2. So A equal 0.6 G. Now next part is we want to find the particle travel distance of particle B. It say that this B is hanging around 0.5 meter above the ground. Now we need to find the time taken to come to this 0.5, and now we have the acceleration, that is 0.6 g and 0.6 g. So we'll put S equal ut plus half a t square to particle B. So S is 0.5, this height, and A is 0.6 g. So we need to find t. U is 0. So 0.5 times 0 times t times half 0.6 g t square. T square equal 2 times 0.5, 1 divided by 0.6 g. So t equal square root 1 over 6.5 times 9.8. You will get the answer 0.1 second. Next question is the total distance traveled by A before it first come to the rest. After few seconds, so the particle will stay here. After another few seconds, this particle will come and hit. Then just after hit, this tension become 0. Then there is no tension anymore. And this one is freely moving after that. And it may stop somewhere here. So it is freely moving and stop somewhere here. So we need to find the distance travel. So for that we can put V square equal U square plus 2AS. But we need to know, we know that when it is at stop, the velocity of V equals 0. But we don't know the starting velocity U. And we don't know A acceleration as well. So if we know that U and A, we can find the distance it's traveled. Let's say this distance is S. Sorry, this is a circle. Now, when there is no tension here, the particle is moving freely, and still it has this 0.08 friction force. So when we put F equal ma to this direction, for this particle without tension, just after it's hit this one, and the tension becomes 0, and this particle start moving freely, and the only force is this one, so minus 0.8 g, times this particle weight is 0.4 times A is, now it is not this A, so it is has a different A. So let's say A1. So A1 equals 0.08 divided by 0.4. Now A1 is 0.2 G. Now we know when it is stop V, value is U. Now we A found out, that is 0.2 G, and now the starting velocity. Now until this particle come and hit this floor, the both have the same velocity. At the time of it stuck with this, we can find the velocity of this one. So the same velocity should have this particle when it start deceleration. So actually this value is minus value, which is a deceleration. Now we'll find the from here to here 0.5 distance is drive, is fall, and V equal U plus AT to particle B. So we need to find U. It is starting from 0, and the acceleration is, that one is 0.6 g, and t we found out that is t is 0.41. Without rounding up, the figure should be 23, 0.4123. Then we can find this v value. So this value is going to be 2.424. So this is hitting with 2.424. So when this, then this particle also have 2.424 when start decelerating, ms minus 1. So then we know u, then we can find s. Now v square equal u square plus 2as to particle a. So v square is 0. So when it's come to the rest, and u square we found out 2.424, 4.2, sorry, 2.424 square plus 2 times a value we found out, that is minus 0. G, and this is s. So s equal 2.424 square divided by 2 times 0.2 G. So this is going to be 1.5 approximately. Then total distance traveled by A, so it is until it's 0.5, this is also moving 0.5, and when it hits another 1.5, go forward and it's come to rest. So the total distance is 0.5. So same distance, this particle 0.5 distance travel until it hits. So A also travel the same length, 0.5, and when it hits after this without tension, so it will move under deceleration with 1.5. We calculate that value. So this is 1.5. So total distance is 2 meter. So at this, in this sum it say that this distance, total distance is given 4.5 meter. It means there are enough, it will not come, this particle A doesn't hit the pulley. There are enough length. enough distance.